Hi guys, good evening. So we are starting the final part of work power energy, and many of the calculations are there. Hope that you did the homework. Kali don't have the teaching. The others must have done the homework. And Ravishka is here. Good morning. Yeah, now yes. So now this has to be corrected as power. Early in the morning, this has to be power, not the efficiency. It has to be power, right? So power equals force into velocity, and you should know that the velocity should be constant here. Velocity here should be constant, right? So the velocity into force, and the velocity should be constant, and even the force is constant. The force doesn't change, and the velocity also doesn't change, right? Can't be changing, right? Yes. So we discuss all the questions from the this part we did, right? No? Any homeworks were there in this part?
From the seventh question
We could discuss for sure. Okay. Karina everything hani? Everything ha Karina? Okay. Board එක පේනවා? Where's Johan? Right. Okay, guys. So check from the question 7. 1 kilowatt hour is. Now, what do you measure using kilowatt hours? That's a good question. Yeah, the electricity is an answer, yes. But in like the measuring units, what do you measure? It's actually the energy you are measuring, the joules, the work you have done. The kilowatt hour is the work you have done, or the joules you are measuring. Because now the kilo is what? Kilo is just a prefix, right? Like the kilos, megas, gigas, and tera, peta, all are prefixes. Now the kilo is a prefix, so it doesn't have any of the physical quantity meanings, right? It's just a prefix that's a multiplication of 1000 times, right? And what is what? Now, if you are given a sort of, let's say, something like this kilowatt hour, or kgm is minus 1 or 2, something like that, you have to have the knowledge to convert that into a proper unit, or something that we usually use, right? So it's the same here. Now kilo is a prefix. What is what? You have to know what is what. What do you measure using what? Huh? Don't say electricity, not electricity. What is power? Yes. What is power? You are measuring power using the what? So what is power? Hmm? Oh. Yes. That I'm going to teach. Right? So what is power? Work over time. So if we simplify this, now what is work over time, or the energy over time, isn't it? Yes, right? And the hour is time, back again. And the kilo is just a prefix, that means 1000 times, right? So what happens here now? Time to time cancels out, so what's left? Work, which is joules, right? So you have to know, like me, these kind of conversions you have to know. It's not sort of a conversion, you have to dig into it and find what really happens there. This comes on to actually the measurements, converting the measuring units. So kilowatt hour is, you have to convert, that is in joules. Now 1 kilo is 1000 and that will be 1000 watts, and now in watts, time is in seconds, ne? So hours you have to convert it into, so 1 hour is 3600 seconds, right? 3600 seconds. So what gives it? 36, how many zeros? 5 zeros. 3, 4, 5, right? This is joules. So the answer is given in 1, 2, 3, 4, 5, 6. Yeah, this one, right? 3.6 into 10 to the power 6. This one. Yes? No? Correct? No? Anyone else? Hurry. Kali, Kali don't have the tute. Isuga did the homework. Those are homeworks. Oh, Hari the me. Me kare. Hari. Chamat. Hari. Right. So the next one, not a unit of measurement of energy, right? So not a unit of measurement of energy. Now we already know the joule is correct. That's the measurement of joules, the work. Is there? Huh? Drill? Appaya bagini. Yeah. Now, watt into seconds. It's again what is work over time, and the seconds is time. So that's again energy. That's correct. Newton meter. So it's not, but let's see if there's a better answer than that, because work is forced into displacement. So in that case, the force is newtons, displacement is meters. So Newton meters is somewhat okay. But there's a difference, like you can't use Newton meters for the work done. Why? But there's another physical quantity that you can use Newton meters as the measuring unit. What is it? Yeah, the torque. In the torque you can use Newton meters because it's a measuring unit of torque. Now what is the difference of torque and a work? What is the difference? There's a difference. Okay.
Torque is like in one same place.
And constant radius. Okay. The definition of work done is the displacement that occurs to the direction of force. So the direction of the force and the displacement should be towards the same. But in torque, the displacement and it's not actually the displacement. Yeah, the distance and the force are acting perpendicular to each other. So it's not a work. Now if a work is happening, the force and the displacement should be towards the same direction. Now this is a torque. The force and the distance are perpendicular to each other. That's the difference. Get it? Yes. Bros, get it? Now back row. Bro, got it? What did I say? I got nothing. What did I say? I said something. That will come to the exam and you will have 0 marks for that. Bear it now. This.
Distance and force are highly perpendicular to each other.
And what else?
So torque equals Newton meters.
Okay. And The work done is what? Work done is? I asked like what is the difference? The work done and the torque. Is there a difference? What is the difference? And I'm going to watch the recording back again then. Now this can be taken in that way if you take it. Kilowatt hours is again joules. This one doesn't have any meters or anything, so නේ ඒක තමයි ගන්න බැරි. meters මොනවා හරි තිබ්බනම් ඔන්න work done හරි මොකක් හරි එකට දාන්න තිබ්බා. එහෙනම් answer should be ඔව් මොකක් හරි දාන්න තිබ්බා. දැන් මේක ඇතුලේ meters මුකුත්ම නැහැනේ කොහොමද? so it's not නේ yeah කොහොමද ගත්තේ newton meters ඒක හරි ඒක වැරදි තමයි but correct than this one මොකද අපි work done එක FD නේ force into displacement එක ඒතර newton that's the thing නේ ඒකින් අර answers පහම බලන්න මේ you have to go for the most suitable answer නේ that's the thing right come to the ninth question now this is did anyone do this one? Good. Kiya answer. 600. What do you got? 60. 600. You got the same answer. You got? 600. You got 600. You got 60. What did you got? 600. Right. A motor lifts water from 30-meter deep well to the ground level at a rate of 2 liters per second. The potential energy of the mass of water lifted by the motor in 1 second. Right? Shall we draw this one? Now there is a motor. So what does it say? There is a motor lifts water from 30 meters deep well to the ground level at a rate of 2 liters per second. The potential energy of the mass of water lifted by the motor. Right. So there's a well like this one, 30 meters deep. This is 30 meters. And a motor is there to take out all the water from there, and it says like 2 liters of water. අපි ගමු මෙතන 2 liters of water in a second මේක උඩට යනවා කියලා කියන්නේ. They are asking for the potential energy in a second, right? Potential energy එක second එකකදී කොච්චරක් consume වෙනවද කියලා නේද අහන්නේ. Potential energy of the mass of water lifted by the motor in 1 second, right? So simply what you have to find is potential energy. So potential energy is mgh, right? So now the mass isn't given. What shall we do? Now this is water, right? Yeah. So 1 liter is 1 kilogram, 2 liter 2 kilograms. Now it's 2 kilograms. Because the density is, now density is how much? 1000 kilograms per cubic meter. And if you take it in liters, 1 kilogram per liter. Those conversions you will have to remember because this will also come in fluid mechanics. Right? Fluid mechanics වලත් වෙනවා 1000 liter 1 kilo cubic meters වලින් ගත්තොත් 1 liter 1 kilo cubic meters වලින් ගත්තොත් 1000 kilograms per cubic meter. ඒක මතක තියාගන්න. එතකොට ලේසියෙන් ටක් ගාලා ගන්න පුළුවන්. Now this is 10 and the height is 30 meters. How much do you get? 600 joules. Now that's correct. What happened? Right? So the other thing, is this the total energy of the work done? Or is there anything else? Is it the complete work done by the motor? Is it potential energy only, or is there any there should be kinetic, right? Because the water is moving from the ground level to the from the well to the ground level. So it's moving. So if it is moving, other than the potential energy, it has to have a kinetic energy as well. So if you are asked to calculate the kinetic energy, how would you calculate it? Half mv square. Now the mass is there. Do you have the velocity? Can you find the velocity? How much is the height? Yes, because 30 meters yana kochchara kalakinda? 1 second. So what is the velocity? Yeah, so 30 meters per second. Taking on kinetic energy calculate karna pulon. If you think further, it has an ask, so 600 joules it is, right? Third question. If water is ejected from the above water pipe at a velocity of 90 meters per second, the work done by the motor in 1 second. Right? If the water is ejected from the above water pipe, now it's the same water pump, and what happened? Did I do something? Above water pipe at a velocity of 9 meters per second, the work done by the motor in 1 second is. Now, do you have to consider the velocity or not? We have to consider the velocity. Yes. So, what is the complete equation will be there? The complete work done by the motor will be mgh plus half mv square, right? Half mv square. So mass is 2 kilograms. Now අපි එක හොයාගත්තනේ potential energy. අපි එකකින්ද ඒක value එකක් විදිහට ගමු. How much? 600 joules plus මේක calculate කරමු. Half mass is 2 kilogram. V is given as 9 meters per second, so that's 9 square. So 2 to 2 cancels out. 9 square is 81, right? So together gives 681 joules. Answer is second one. Got the correct answer? Which one? If water is ejected from the above water pipe, this one, which is 30 meters well එකේ ගැඹුරින් වතුර අදින මෝටර් එක. අයි මේ උඩ එකේ කියලා තියෙන්නේ motor lifts water from 30 meters deep well එකකින් කියලා. ඒ මෝටර් එකම තමයි මේ. ඒකින් water eject කරනවා 90 meters per second speed එකේ. එතකොට අර අපි කලින් consider කරපු එකම තමයි. අපි ඒක velocity එක ගත්තේ divide කරලානේ. දැන් මේකේ velocity එකක් දීලා තියෙනවා. ඒකින්ද අපිට kinetic energy එකයි potential energy එක consider කරලා calculate කරන්න තියෙන්නේ. So 681 joules. Right. We discussed this one, did we? Huh? Q&A? Right. Again, this one we discussed, right? The power equals force into velocity, and the velocity should be constant here. Right. Now the efficiency, right? So what is efficiency? Efficiency is, now usually the machines are there, right? So many machines are there, and efficiency is like how much of a work is done depending on the energy is given to the machine, or the how much of power is given as an output depending on the power given to the machine. Let's say something like this, like let's say someone is going to the gym. Say an auntie is going to the gym, right? So auntie is going to the gym, and she takes an apple, and she eats it and generates a power of, let's say, 20 watts. While she, like when she eats the apple, it generates a power of 20 watts, right? And she is lifting the dumbbell, right? එක අතකින් apple කනවා, අනිත් අතින් dumbbell එක ගන්න. Can happen, right? Don't look at me like I am the auntie. හරිද? Now she is eating the apple in one hand, the other hand she is lifting the weights, right? Let's say the power which is done when lifting the weight is 10, right? But the energy input is 20. Now the rate of rate of doing the work is 10 watts. Right? Input එක 20, output එක 10. Now what happens to the rest of it? Is wasted as what? Sometimes it has heat නේ. Otherwise මොකක් හරි ස්වෙට් එකට යනවා, ස්වෙට් වලට යනවා. හරි. ඒ වගේ මොන මොනාට හරි මොකද වෙන්නේ? ෆ්‍රික්ෂන් එකකින් හීට් එක එනවා නේ. ෆ්‍රික්ෂන් එකත් එක්ක හීට් එක එනවා, ස්වෙට් එක හැදෙනවා. ඒවට 10 වැය වෙනවා. 10 watts යනවා. Other 10 is the work done, right? So what is the efficiency there? She was given 20 watts, right, while eating the apple. Right? She was given 80, like the 20 watts while eating the apple, and only 10 watts were the work. නේ මෙච්චරයි ආය වැඩ කරේ. And if you took it as a percentage, it will be how much? 50%. So only a 50% of efficiency is there in that machine. Is it good enough? Not good enough. නේ? For a machine, it's not good enough, right? So what happens, like why has this happened now? Why has like 50% of energy is wasted? Why do you think the 50% of energy is wasted? Would it happen to a usual normal person? Eats a apple of 20 watts and only like the output work is done 10 watts. Would it happen to a normal person? No. So why do you think that this happened to the auntie? What is the reason this happened to the auntie? Why do you think this happened to the auntie? Eh? Yes, that can be also taken. Most probably the energy that takes to burn the fat is more. So that means she's fat. That's the only explanation can come up with, right? She's fat. Because she's fat, more of the energy is taken to burn the fat. So the more of the energy is going to burn the fat, the work can be done is less, right? So that's how the fat aunties are. Can't work. Don't work. Don't take it the other way. Like can't do the usual work, right? So same happens to the machines. What do you mean the machines? Like the motors and everything, right? So what happens there? What is the resisting part? Now that is the resistance. You know, the fat becomes the resistance, right? So because we have to pay more energy for burning the fat. Same way happens to the machines. What is the resisting part there? The friction, yes. In the machines there is a friction that you have to work against, right? You have to overcome the friction when you are like a machine is working, right? So you have to give energy for the energy to work against the friction as well. So that energy is wasted, right? That energy is wasted. So the work done is less than the 100%. We have to give energy to do the work and to work against the friction as well, right? So that happens in the machines. So like the majority of the machines aren't working 100% in efficiency. දෙනවට වඩා අඩුවෙන් තමයි ආ work එක එළියට දෙන්නේ. ඇයි? There's a friction or the resistance is there. Some sort of a resistance are there. So same in like the human machines. We are all same. If you have like less resistance, you can work. Heat එක efficiency එක 100. ඒතර work එක කළාම නේ. නෑ 0 වෙන්න බෑ කවදාවත්.
heat එක කොහොමද heat විදියට යන්නේ.
ඔව්.
taste එක ගියා දාගෙන කොහොමද heat එක එන්නේ.
නැහැ ඒ කියන්නේ ඔව් ඒ කියන්නේ දැන් heat එකක් කොහොමත් එනවා fat වෙනකොට heat එක වැඩි. ඒ කියන්නේ heat එක වැඩි කියලා කියන්නේ අර fat එක burn කරන්න යනවනේ energy එක. ඒ energy එක වැඩි කියලා කියන්නේ.
මම heater එක කියන්නේ.
යන්නේ heater එක. electricity.
ඔව්.
මගේ joke එකක්.
Are you should sell it before. Are you talking about the heater? No, because heater would be fine because the waste is so anyways the heat. Nice. We have to tell it. මං හිතුවා අර මේ ආන්ටි ගැන කියනවා කියලා. You're saying about the heater. Good. Yeah, that's true. Nee, heat එකක even the waste is a product because heater anyways produce the heat. So resistance it doesn't matter there. That's what you're telling. Good. Right? Understood. Sorry. Sometimes it's really hard to be a genius, right? Because the people don't understand your jokes. Right. So you understood. Now that is efficiency, right? That is efficiency. Right. So how do you calculate the efficiency? The output of a machine compared to the input and the 100% of it gives the efficiency, right? So this output and input sometimes can be energy and sometimes can be power as well, right? Can take the power, can take the energy, doesn't matter, right? So come to the truth. Efficiency, power output or energy output over power input or energy input, right? Into 100% gives the efficiency. Get it? Yes? Right. So if you all want to be a good machine, what should you do? Should have like if you all want to be a good machine, should have less fat in case. Good thing Johan is. Johan is not here. අපි height එකට එයාගේ තියෙනවා නේ. Yeah, that's true. අපි එහෙම කවුරුත් නැහැ නේ. Fat බොසාලා නැහැ කවුරුත්. Only the Right. Now did you all do these calculations? Correct. No, I gave the homework, did I? Kiwa? Rose. Is it very nice? Then only 2 minutes will be given to the question. Yeah, per question 2 minutes. We'll reduce it to 1. Did you all do it? You tried it at home? Yeah. Even you? You're gonna regret things, huh? Don't do it like this. Study at home, otherwise these things will be difficult. Now do it. Again, Ankara. And make it again. Chamatona 2 එකයි 3 එකයි නේ. That's all නේද? 1 Yarn is coming. hop in. Done the first question? That's easy, right? Papers, model questions, papers. Dino. Pull on. That's okay. Shall I do it? The first question. What did you got? Third answer. Third. So what do you got? Third answer. Now the first one is easy, right? If the object moves a distance x under this force, the work done is. Now the displacement occurs in the horizontal plane but the force is acting in a theta angle, right? So in the definition it says the force and the displacement should be the same direction. So we have to take the force acting in the direction of displacement, which is how much? F cos theta. F cos theta, right? So the work done is F cos theta. The displacement is x. So F cos theta x. That was easy. Second question, when the velocity of a moving object is doubled, the factor by which its kinetic energy changes. Now this is a good question. Now tell me, we even discussed this one, right? Mikala? මේ question එකද කරේ වෙන එක? Even I can remember. නේ අපි මේක discuss කරා මේකේ තියෙන එක. ඒ කියන්නේ the velocity majorly depends on the the kinetic energy. I said it wrong. The kinetic energy majorly depends on the velocity rather than the mass. Why? Because අපි mass එක double කරොතින් kinetic energy එක it will just double. But if we double the velocity හතරක් වෙනවා නේ. So rather than අර මේ ගල් පෙරලනවට වඩා බුලට් එකක ස්පීඩ් එක වැඩි කරන එක it's more efficient when it comes to killing a person. And that's a thought I had. I don't know why. නේ I'm not saying that way, but the meaning is that අර දැන් ලොකු මෑස් එකක් තියෙන ගලක් පෙරලනවට වඩා බුලට් එකකින් වෙඩි තියෙන එක yeah, so it has more energy than අර ලොකු ගලක් පෙරලනවට වඩා පොඩි බුලට් එකක energy එක වැඩි නේ. I have some cruel ideas, I don't know why, but that's the example that came to my mind, right? So අපි එක බලමු. EK equals half m. Now they are doubling. Now let's say this is the usual equation. In the second one, they are doubling the velocity. So 2v, and the complete 2v gets the square. So what happens? 2v square is 4. So 4v square නේ. එතකොට 4 එක අපි ඉස්සරහට ගත්තොත් m 4v square. එතකොට 4 එක අපි ඉස්සරහට ගත්තොත් that is 4 times half mv square. So it's 4 times this one නේ. Velocity එක double කරොත් the kinetic energy becomes 4 times greater. And rather than increasing the mass, it's easy if we increase the velocity. නේ. That's something you should try. Velocity එක වැඩි කරන්න තමයි try කරන්න ඕන. Right. So the third question, 50-gram bullet travels at a velocity v and hits a wooden block. The kinetic energy of the bullet is completely converted into thermal energy. If the amount of thermal energy is 250 joules, they're asking for the value of v. What is this now? How do you apply this? Exactly. So what is that? The theory behind that? Conservation of energy, right? මේකෙන් මොකද්ද වෙන්නේ? kinetic energy එක තමයි convert වෙන්නේ thermal energy. දැන් ඔන්න ඕක ඔයාලා decide කරන්න කැලේ ලියනවා ගොඩක් හොඳයි. අපි we discussed the essay question the last week. ඒකෙදි අපි අර අන්තිම කැලේදී ගත්ත half mv square එක තමයි work done against friction එකට convert වෙන්නේ කියලා මතකද? අන්න ඒ වගේක් ඔයාලට ඒ කියන්නේ ඔයාලට තීරණය කරන්න එනවා වෙලාවක්. අන්න ඒ වෙලාවට use your brain properly. හරි. ඒක ඔහොම නැතුව වෙන විදිහකට එන්න පුළුවන්. ඒ වගේ වෙලාවට අර හිතන්න. හරි. මේකේ වෙන එකක් වෙන්නේ නැහැ කොහොමද? මේක කොහොමවත් තීන එකක් අරකට කන්වර්ට් වෙන එක තමයි වෙන්නේ. සෝ මේකෙදි වෙන්නේ මොකද්ද? half mv square එක heat එකට කන්වර්ට් වෙනවා. අර අපි හදපු calculation එකේදී last week the half mv square was converted to the work done against the friction. Now the thing is you know it. හරිද? You know it. But the way the question is asking you are getting confused. හරිද? So have some experience, have some knowledge about it, how the questions are there. නේ. එතකොට අවුලන්නේ. ඔක අර අහන විදියෙන් තමයි වැඩි අඹරන්නේ. නේ. පොඩ්ඩක් බය කරලා අහන්න. එතකොට ඒක ගන්නට කරගන්න ඔව්. ඇප්ලිකේෂන් එක කරනකොට මේකේ ලිමිට් එකක් තියෙනවා. there's always a limit. හරිද? නිකන් අර මේ law of relativity එකේ තියෙන ඔය black holes වල තියෙන mathematics part එක වගේ වහන්නේ නැහැ. හරිද? So there is always a limit. Within that limit only the questions will come. නේ. ඒ හින්දා know that limit, think under that limit and have the experience, you will do it. එහෙම නැතුණාන් පස්සේ තමයි you are getting panic and me thinking මේක වෙන එකක්ද දන්නේ නැහැ, මේ අහන්නේ දන්නේ නැති මොකලොත් දන්නේ නැහැ කියලා දන්න එකක් කරන්න නැතු වෙනවා. හරිද? ඒකට experience තමයි වුණා. Hari, 50-gram bullet travels at a velocity of v and hits a wooden block. The kinetic energy of the bullet is completely converted into thermal energy. The amount of thermal energy is 450, the velocity they are asking. Now the thermal energy is equal to half mv square, which is the kinetic energy, right? So thermal energy is 250 joules and half the mass is how much? 50 grams. We have to convert it into kilograms. So I'm dividing it by 1000. Now this is kilograms. We have to find, right? V square. Now the V square is there. We have to find V. Now how many 50s are there to the 250? 4. And this is 2000. 2000 comes to this way. So 2000 into 4 is 8000. Yes. So V square equals 8. Huh? Is it 5? 5 ne? Sorry. 50 over 5 තියෙනවා නේ. 250 over 5. Yeah. So 2000 into 5 is 10,000 ne? So it's 10,000. So V square is 10,000. Then V should be 100. 100. See? That's it. See what a small bullet can do. be either, I won't say that. Fourth question. Right? The horizontal velocity component of an object of mass m moving at a constant velocity along a direction inclined at 30 degrees. The horizontal velocity component is v. The kinetic energy processed by the object is, now what does it say? Horizontal velocity component of an object of mass m moving at a constant velocity along a direction inclined at 30 degrees. Right? So there's a mass, like an object with mass, and it moves in direction. It says like it has a component in 30 degrees of an angle, right? It has a component in 30 degrees of angle, and the horizontal velocity component is v, right? The horizontal velocity component is v. The kinetic energy processed is of mass m moving at a constant velocity along the direction. Yeah. So they are asking for the kinetic energy process. Now, now this is a bit confusing though. The horizontal velocity component, No. The question says the horizontal velocity component of an object of mass m moving at a constant velocity along a direction inclined at 30 degrees. The horizontal velocity component is v. Now the velocity component is v. It's this one, not this one. Right? Horizontal velocity component is v, it's not the actual velocity, it's the component, right? Now the horizontal velocity component is there in 30 degrees of an angle, right? And the kinetic energy processed is, now the object moving has a component in 30 degrees of an angle, and the component is v. They are asking for the kinetic energy of the object. So do we take the component of the object or the actual velocity of the object to calculate the kinetic energy? You have to take the actual velocity, right? So it's in the horizontal plane because the component is taken in 30 degrees. Ne? So now
direction of the incline 30 degrees again.
the horizontal velocity component of an object of mass m moving at constant velocity along a direction. Yeah. Yes. Along a direction inclined at 30 degrees. Yes. The horizontal velocity component is v. So it's nothing much. So half mv square. It's half mv square. The first answer, is it? Oh. Now listen. It says the horizontal velocity component එකක් තියනවලු ඒ පැත්තට තමයි move වෙන්නේ. Moving constant velocity along the direction inclined at 30 degrees. Velocity component is v. It's actually v is this one. The kinetic energy processed by the object is. Now this, as the question, like if you take the details as the question says, it should be half mv squares anyways, because the එතකොට එහෙනම් මේකට තමයි half mv square දාන්න ඕනේ. මෙයාට දාලා බෑ. මේකේ කියනවනේ හැබැයි component එක පැත්තට move වෙන්නේ කියලා. එතන තමයි කචල් එක තියෙන්නේ. If it wasn't moving in the direction of the component, එතකොට කෙලින්. Shall we mass එක weight එක down. Yes. We don't consider it because we only consider the velocity. kinetic energy, right? Not the weight. Shall we change the question? The horizontal velocity component of an object of mass moving at a constant velocity along a direction inclined at 30 degrees. We'll change the question as horizontal velocity component of an object of mass m.
Mass is moving horizontally.
එහෙම ගමු. Along the direction, the horizontal velocity component අපි මේක ගමු along a direction inclined at මෙන්න මේක අයින් කරන්න වෙනවා. Along horizontal plane, right? Horizontal plane එකේ යනවා කියලා ගන්නකො, right? And the horizontal velocity component of an object. මෙතනට අපි ගමු angled 30 degrees කියලා. Angled 30 degrees of එකට with mass m moving at a constant velocity along a horizontal plane. The horizontal velocity component is horizontal only. The velocity component is v, the kinetic energy possessed, right? So now this is the velocity component. Now this is the actual velocity v1, right? So that's what happens there. So we can't take the velocity here. Instead we have to take this one. Now what is this one? How do you take it using the v? How do I take v1 using v? v1, yeah, v1 cos 30 should equal to v. Now v1 cos 30 is root 3 over 2 equals v. So the v1 equals 2v over root 3. Yes. Now that's it. That is the actual velocity that the object is moving, not the component. Now you have to put half m is equal to this one. How do you do it? Just put Ek equals half the mass is how much? Doesn't matter any. And the v is now 2v over root 3 and its complete square. So what do you get? Half m 2v square is 4v square and root 3 squared 3. I like the kittens. What are you eating? 2 to 2 cancels out. What do you get? 3 over 2 mv square. 2 over 3 mv square. It's even there. අපි ඒක ගමු ඒ question එක ටිකක් ඊට වඩා decent. Are you eating it? Thanks. ඔව්. v එක තමයි දීලා තියෙන්නේ.
ඒකට ඒකේ force එක act වෙන්නේ angle එකේ.
Force එකද? Force එකද?
ඔව්.
හැමදෙස්සම මොමන්ට් එකේ ඩිරෙක්ෂන් එකේ නේ force එක තියෙන්නේ. mv ඩිරෙක්ෂන් එක තමයි force එක තියෙන්නේ. Force එක ගැන consider කරන්න එපා. The horizontal velocity component of an object angle 30 degrees. the question means is ඒකේ component එක V but moves in a horizontal plane and the
ඒක මෙහෙම ඉන්ක්ලයින් එකෙන් හම්බ වෙනවා.
ඔව්.
මෙහෙම පාස්
තම-
වෙනවා ඒකේ
kinetic energy හොයන්න කියලා. Understood the question? Now we recorrected it, but it still looks ugly though. I know. But just wanted to give that idea. I can velocity එක තියෙන angle ඒ කියන්නේ velocity component එක තියෙන angle එකකින් නේ. ඒතර අපි kinetic energy දානකොට velocity component වල නෙමෙයි දාන්න ඕන. The actual velocity එකට. Right? Come to the question number 5. The factor that an object with moving mass cannot have. Right? Factor that an moving mass cannot have. Johan, answer this. A factor that an object with moving mass cannot have. Aha. Yes. Does a moving mass have a velocity? Yes. Momentum? Yes. Mechanical energy? Yes. Kinetic energy? Gravitational potential energy. Doesn't have to have all the time, right? Because we can take any level as 0. So it can be 0. So yeah, fifth answer. Did you do this question? This one. මේකත් කරා මෙහෙදි ඩිස්කස් කරාද අපි
නෑ නෑ මගේ මාර්ක් කරා
අපි මෙහෙදි කරේ නෑ අපි කරගෙන මේකත් එක දැන් කරගෙන now come to the question number 6. An object is released from an airplane traveling at a constant speed in the air. The graph showing how the total energy of the object changes with the time. Right? With the time. Huh? We still didn't confirm it. Don't know. Paha. Tuna. Hatara. What do you say? An object is released from an airplane traveling at a constant speed in the air. The graph showing how the total energy of the object changes with time. What do you mean total energy වෙනස් වෙන්නේ? Yes. What do you say? Kali. Tell me your opinion. What again? They ask about total energy. The guy has a point. What happens to the total energy? What do you say? What happens to the total energy? Think. No change.
Constant speeding.
Yes.
constant speed එකේ
Hmm?
constant speed එකේ විතරක් කියලා energy change
නෑ නෑ එහෙම නෙමෙයි අහන්නේ.
කොන්ස්ටන්ට් ස්පීඩ් කතාවක් අදාළයි.
no energy කියලා
No?
energy කියලා මොකද change
asking? Not doing the answer.
දැන් මම කියන්නේ අරක පහළ අරක අඩු වෙති අරක වැඩි වෙනවා කියලා.
අර කරක්
පොටෙන්ෂල් එනර්ජි අඩු වෙති කයිනටික් එනර්ජි වැඩි වෙනවා.
that's true. Potential පල්ලෙහාට එනකොට potential energy එක අඩු වෙනවානේ. relatively kinetic energy එක වැඩි වෙනවා.
ගණන්ගේ බෝඩ් එක දාන ගණන් නේද ඒවයිත් එහෙමයි.
agreed නේ පල්ලෙහාට යනකොට හරිනේ potential guy has a point. Agreed. So what happens, the potential energy decreases getting down and the velocity increases, huh? And she was laughing, I was no, that's true, guy has a point, right? So what is the answer? Yeah, energy is constant. Now what about this constant velocity there? Do we have to consider it or not? Yeah, so the plane is traveling at a constant speed in the air. So the graph showing how an object released from an airplane traveling at a constant speed. Yeah, so the plane is traveling like this and it releases an object. Now the object has the velocity component of the plane as well. ඒක තියෙනවා. හරි. හැබැයි අර height එකේ තියෙන energy change වෙන එක ඒක පල්ලෙහාට එනකොට ඔව් potential energy අඩු වෙනවා, kinetic energy වැඩි වෙනවා. දැන් මේක ඒක downwards නෙවෙන්නේ. It's applying downwards, right? The vertical එක අපි ගත්තොත් vertical එකේ ඒක තමයි වෙන්නේ. හරිද? vertical එකේ අපි ගත්තොත් potential energy එක kinetic energy වලට convert වෙනවා. ඔව්. horizontally velocity එකක් තියෙනවා ඒකෙදි. හැබැයි horizontal velocity එක පල්ලෙහාට එනකොට වෙනස් වෙනවද වෙනස් වෙන්නේ නැද්ද? horizontal velocity එක පල්ලෙහාට එනකොට වෙනස් වෙනවද නැද්ද? නෑ. වෙනස් වෙනවා. ඇයි වෙනස් වෙන්නේ? යාට we don't consider the air resistance in the physics, huh? Normally තිබ්බොත් අඩු වෙනවා, but when it comes to the questions that we do, we don't do that here. No resistance is there, so the velocity doesn't change. So that velocity is all like again constant, so that means that kinetic energy doesn't change. So it's again constant, yes. The answer is 5. Correct. Then මේ පැත්තට යන velocity එක change වෙනවද? change වෙන්න බෑනේ, මොකද resistance එකක් මෙහෙට නැහැනේ against. ඒ හින්දා ඒ velocity එක පල්ලෙහාට යනකම් කොහොමත් ඒ විදිහටම තියෙනවා. ඒතර ඒකත් constant. ඒක change වෙන්නේ නැහැ. So the total energy is, yeah, true, constant. නේ? Total energy constant 8. Right? So the question number 7. A motor vehicle is moving along a horizontal road with a constant velocity. When the frictional force exerted by the road against the motion of the motor vehicle is F, the power of the motor vehicle engine is? It's a simple one. This is a theory question. Fv, because power is F into V, force into velocity. Yes. So the answer is 2, right? 2, 1. Right. The kinetic energy and the potential energies of an airplane flying at an altitude of 500 meters are equal. The speed of this airplane is? How do you calculate it? Anyone confirm it? 100? 100? No. I'll do it now. That's enough. What is answer? 100. somebody 100. How do you do it? So the question says the kinetic and the potential energies of an airplane flying at an altitude of 500 meters are equal. So that means the energy in 500 meters and the velocity, like the kinetic energy are equal. Ne? mgh ekai half m square ekai equal. That's all. So equal the two of the mgh and half m square. So mgh, what happens here? Mgh is equal to half mv square. Now m cancels out. G is 10, height is 500 equals half v square. V is what? V is that what we have to find, right? And this is 5,000. 5,000 into 2 is 10,000. Now we simplify this one. V is 100. V is 100. Correct. Correct. Right. Question number 9. Any answers? Karna. Do it fast. Oh, then. Bro, sorry. I was checking a comment. Hey, yo, hold on, it's not there. We didn't send the link. Now the link isn't given for everyone. No? One of the paid person gets the link. Link, online link can be provided. They're restricting. That's true because they are. Oh. An electric motor consuming power at rate of 500 watt lifts a load of 12 kilograms. If the load moves vertically to a height of 10 meters in 5 seconds, the time is given. So take the power. Yes, step 3. Anyone confirm it? 3? Okay. So what is the formula here? The efficiency equals output over input into 100%, right? So the output is the work done. එතකොට lifts the load of 12 kilograms if the load moves vertical to a height of 10 meters in 5 seconds. So that's the work output, which is 12 kilograms of a mass, 10 ms minus 2 gravitational acceleration, height is 10 meters. This is mgh, right? And the work is done within 5 seconds. So this is the work output. නේ? එයා කීයක් එනවද? So 240 watts. නේ? 240 watts. Now if I apply to this equation, the input is 500 watt. 240 watt is the output. You have to take the 100% of it. So 240 divided by 5 is it 48? 48%, good. Correct. Right. This question, a pump removes 36,000 kilograms of water per hour from a 100-meter deep well. The efficiency of the pump is 50%. They are asking for the power of the motor in kilowatts. Can you do it? Hey, what should I do now? $12 kya hai? Anybody have kya bine? Bro bhai. Kya bine? Man kya bine thi. I don't usually eat. The shiny is back. Connection issues to pata. Troubles are there. And people. Now the ladies back need some support doing the questions. You do, right? You need some support doing the questions, do you? Huh? Not right now. Just when you are studying. Yeah. So the people here can help. The questions, bros. Now, if you can come early a little bit, like not other, the next day other, the next week other. Other in a time travel karne no. Like when? What time? We're finishing 1. Yeah, at least 1:30 if you can come. Product support දෙන්න doing the calculations. ඒක ඔයගොල්ලන්ට හොඳයි in one way. For the work and force questions. නේ? Support දෙන්න work and force questions දෙකම. Majorly the force. Force එක තමයි majorly ඕන. ඒ දෙකට පොඩි support දෙන්න because that's one way improving yourself and it's a good thing for them. නේ අපි කාටද දෙන්නේ? රයන්ට හරි රවිෂ්කට හරි. රයන් පොඩි සප්‍රයිස් දෙන්නේ. අත යහන්නට කමන්නේ. සපෝට් එකක් දෙන්නේ මේ ඇඩ්මිෂන්ද? එන what? Against Ramadan? English day වගේ අද. Like, do you play the instruments or something? What? Guitar? Nah. හොඳට පුළුවන්. පොලෙත් ගාන ඈ. පැරමුණක් ගාන පොලේ. Easy. අපිටත් ගාතේ. Okay, that's fine. Now you're coming the evening class, right? And me bring it sometimes we can sing here. We have singers, right? We have a musician back there. You're playing an instrument, right? What do you play? Guitar? Huh? Drumsticks? Ah, the drums. Okay. What are you laughing at? Tell me, what instrument do you play? You all know the instrument he's playing. Right. Shh. Did you all get the answer? No, not yet. Okay. Power went out. Okay. Bros, we are still at 10. We are still in 10. Equal, what happened? Yeah. Doubts? Tell. I mean, now pump remote 3, so what about from 100 repair. Now MGH ni 3,600, no 36,000 of kilograms, 100 meters udata yana per hour. Now the time is there, weight is there, height is there. So MGH is there and the time is there to take the power. You divide it by the time, you get the power. And that will be the output anyways, because that's the work done, the actual work done. The efficiency of the pump is 50%. Now the efficiency of the pump is 50%. They are asking for the input, power input. Now that is the power output that you calculate as MGH over time. Got it? No. You calculated the output, and the efficiency is output over input into 100%. That is 50%. You have to calculate the input. Yes. 1 liter is 1 kilogram. Oh, parna puskara putaka dibba. No, not like that. 1 liter of water is 1 kilogram. It's a general knowledge, yes. What do you mean 60? Oh.
2 liters 2000 milliliters centimeter or cube density.
Yeah.
2000 into cube centimeters can 200 centimeters.
That's a total. You don't have to go that far because.
I can go 1000 liters 1 kilogram.
Oh, because the density of the water is 1000 kilograms per cubic meter. So if you are converting it there, you have to come from there. The basic units. Yeah. You don't have to because just remember. Oh, because these are the MCQs. Nobody knows how you got the answer. No, 1 cube is 1000 kilograms. එහෙම බටයක් ගිහිලා අහන්නේ. බටයක් ගිහිලා අහන්නේ කියන්නේ oh, because that's me conversion එකක්නේ. So conversions can be there some convert කරලා ගන්න ඒවා තියෙනවා. We did something like that also. But there's no point. So that's usually the general knowledge. Yeah. So now it's general knowledge for you guys. You understood it, huh? They also remembering. මතක් කරන්න මම කියන්න. මං කිව්වා ඔයගොල්ලෝ අතහැරලා එන්නේ නැහැ දැන්. එහෙම කියලා. මං කිව්වා. හරිද? What is the answer? Answer 4. Is it? 4. It's okay. Not yet. 4. Kali. Now Kali is working, ne? Are you studying? Enough? Then join the people, they are studying. As a group, at least. Right, so now listen. We have to take the work output. I'm shiny. Put the answers if you're there. She's there. Put the answers. So you have to take the energy output, so the work output or the power output, and they are asking for the power of the motor. Yeah, that is the power input, right? The power of the motor is the power input, right? And we can calculate the power output using these details, right? The pump removes 36,000 water per hour from a 100-meter deep well. That through that we can calculate the power output, right? And the efficiency is given, so we can easily calculate the power input, right? How do you do it? Now 36,000, 100 meters per hour. That's the output. I'm going to calculate it, right? So a well is there, 100 meters, right? And a motor is here, taking all the water up, and it takes 36,000 kilograms in an hour, right? In an hour. Now using this you can calculate the output, right, or the work done. The output is the actual work done, right? So the output will be mgh over T, right? So mass is 36,000 kilograms, the gravitational acceleration is 10 ms minus 2, height is 100 meters, time is 1 hour, that's 3,600, so it cancels out, right? Only 10 is left, that is 100,000, 10,000. So 10,000 watts is the output, and the efficiency is 50%. So you are asked to find the input. Now we know the equation. Efficiency is equal to output over input into 100%, and here the answer says it's 50%, right? So equals output is 1000 watts over the input and to 100%. So simplify it, find the input, that's all. So 100% to 100% cancels out. 50 to 100, there's 2. So input equals 1000 into 2 is sorry, this is 10,000. So 10,000 into 2 is 20,000 watts. Yeah. So that's 20 kilowatts. In kilowatts, that's 20 kilowatts. So the answer is 4. You haven't got the answer 4? Nice. Who wants to write it? Kali got the answer 4? Yes. So don't want to answer it. Me write it. Shiny got the answer 4? Shiny me arang inna ona. Right. 11th question. The time taken by a crane with a... Yeah, I'm just reading it. I'm doing it. The time taken by a crane with a power of 11.10 kilowatt to lift an object with a mass of 200 kilogram to a height of 40 meters is. Do it. Question is asking the time taken by crane with power is given, and the work done can be calculated.
ඒකේ ආත්මයට
Hmm?
ඒක රවුන්ඩ් ඔෆ් කරා.
Round off कर देते. What is the answer? 3. 3.
කියන්නේ ඒක රවුන්ඩ් ඔෆ් කරනවා
Here
මට 7.2 ගන්න.
7.2 doesn't round out to 8.
Closest
Eh?
to 8 කියලා.
Somebody confirm it.
කිලෝවොට්ස් ඉස්සෙල්ලා වොට්ස් කරලා ගන්න ඕනේ.
Yes.
1000 වලින් මල්ටිප්ලයි කරන්න.
Yes.
equals to work turnover time.
Yeah.
Work එකට NGH දාන්න පුළුවන්.
Yes.
So that is 200 into 10 into 40.
2000 into 40 is 20,000 into 4, 80,000. Yeah. So you divide 80,000 by
11,100.
11,100. What do you get? $7.2. Okay. The time taken by a train with the power to the train object with the mass of the height 40 meters. Bro, confirm the answer. What do you got?
මට හතෙන් දෙකක් ගන්න.
Ah, it's the answer. Yeah, that's the answer.
ඒක උත්තර.
Yes, yes.
මේ එහෙම උත්තරයක් නෑ.
එහෙම තමයි අපි ඉන්නේ හැමතිස්සෙම උත්තර දාන්නේ. අපි උත්තර නැතිවවත් දාන්න.
මම
Hey.
බලනවා මොකන්ද එනවා
නෑ නෑ. ඒකේ උත්තරේ සමහරක් අහට. So even you can round it off නේ. 7.2 නේ.
7 ගන්න round.
Yeah. So the approximate answer is
8.
8.
So 6,000.
Yeah. Within brackets ලියන්න 7.2 though. This doesn't happen in the proper exams, don't worry. Oh, come on. Now do this one. The energy huh?
ඒක අමාරුයි.
Nah. Nothing is amaru. You try it. One day you can fly. The energy required to accelerate a motor car from rest to a velocity of 10 meters per second is u. The energy required to increase its velocity from 10 meters per second to 20 meters per second is 2u or 3u or 4u. What do you say? U. Who? Hint එකක්? What do you mean? The energy required to accelerate a motor car from the rest to the velocity of 10 meters per second is u. So that's one energy, right? So this energy is u. And the energy required to increase the velocity from 10 to 20 is now the final velocity will be 20, right? The energy, I'm saying that if we take it in velocity times, now the final velocity, the final kinetic energy has a velocity of 20, and you can calculate the kinetic energy there. And the initial the initial kinetic energy has a velocity of 10. That is the energy there at the velocity 10, and this is the energy at 20. So compare these two. Energies දෙක compare කරන්න 10 වල energy එකයි 20 වල energy එකයි compare කරන්න 10 වල එක u නම් 20 වල එක this much නම් u times කීයක් වෙනවද 20 එකෙන් ගන්න that's all
Sometimes ගන්න rest එකේ ඉඳන් 10 එකකින් ඉඳන් යන්නේ
යුම නම්
no
ඒ 10 ඉඳන් යන්නේ
velocity difference එක 10 මනේ.
අර 10 ඉඳන්
no don't take the velocity difference they are not asking for the difference
10 to
the energy required to increase the velocity from 10 to
20.
oh so take the energy at 10 take the energy at 20 එතන ඉඳන් එතනට තියෙන energy එක දෙන්නවා She said get the wrong answer 3. Okay. I think the power went out again. What is the answer? 2U. Huh? 2U is it? Okay. What do you say, bro? Say 2U or 4U? Let's say now it's moving in this line, and here the velocity is 10 ms minus 1, and it moves here, and now the velocity is 20 ms minus 1. Now what will be the energy here? Half m. Now is the mass 9? mv square. Now the m is 10. 10 square, that is equal to u. Make it simplify karama. 10 is 100 ni. 100 divided by 2 is 50 m equals u. Now what about the energy here? Half mv square. Now the 20 square, that is 400. Now if you divide it, how much do you get? 400 divided by 2 is 200. 200 m, isn't it? So u is 50 m. Now how much is 200 m? 4. So it's 4 u. Correct answer is, even the correct answer is 4. Okay? 4 u. Is required to increase the velocity from 10 to 20 s. Nothing happened. Right? Okay. We only discussed this question, right? Yeah? Antimiki, Antimiki? Make it. Rubber ball. BAK? Tuna. What about the first and second? BAK? No, I'm asking this question. He's asking for the third question. Can't accept. Me then hadu? Bro, you are next level. Now try this question. Now you should try the previous question. Discussed it. That kind of a question can come. No, the previous one. Yeah, the 4U, bro. This one. Then put on. Good. This one. It's a really simple thing, isn't it? Muladi. Girls, take some advice from the The Penuja, the other part is what?
මොකක්ද?
Penuja what?
ෆන්සි.
The surname?
ඩිෆොන්සේ.
Huh?
ඩිෆොන්සේ.
What?
ඩිෆොන්සේ.
D. Fonseca. I take the advice from Penuja D. Fonseca. Why not? Computer genius someday, ni?
බලමු කවදාද. නෑ මම හිතගෙන හිතන්නේ එහෙම.
And you will be, and I'm 1000% sure about that.
මම කෝස් එකක් කරනවා මට A level කියන්න කලින් ඒකේ software engineering කෙනෙක්.
Doesn't matter. Course name, you have to think about
A
the.
level කියන්නේ. හරි A level කරා.
Not about the even A level. Or real work. Real work like real time works kind of. Industry की तीन real time works.
ඒකෙන් industry එක යන්න පුළුවන්.
एक किल्ල වැඩ කරන එක තමයි.
මම කියන්නේ experience ගන්න යන්න.
That's a good thing. So you're totally fine with the A-level ICT, right? A-level ICT is like too simple for you, is it?
මම ඒක ලේසි. ආයෙත් ලේසි නේද?
ඒක කිසි අවුලක් නැහැ. So you only have to manage the ET and SFT. Everything, you have to put some effort for anything. You have to eat. You have to study. Nothing to do. So I have a doubt in the 12th energy in the 12th. Guys, shall we go to the 12th question? Energy from 0 to 10 is 50 meters. Energy from 0 to 20 is 200. The energy from 10 to 20 meters is what is asking. What is asking the question? So shouldn't it be 200 minus 50? That's 150. Bro, that's somewhat correct. Now the girl got a point. Let's come to this one. So what she's telling is correct. The energy required to accelerate a motor car from the rest to a velocity of 10 meters per second is u, right? So it's from the 0 to here is u, which is 50 meters. So it's not 50 meters, 50 m. The energy required to increase the velocity from 10 to 20 is they are asking. So what she's telling is like the energy from 0 to 10 is 50 and the energy from 0 to 20 is 200 m. Is that correct? What do you say? What she is telling is like energy from 0 to 10 is 50. That's correct. And she is again telling energy from 0 to 20 is 200 m. Eh? The energy required to increase the velocity from 10 to 20. No, that's true. That is correct. Now 0 to 20 is 40. So the question is asking to increase it from 10 to 20. So the energy gap here is 50. Ne? 50. And this should be 150. So the energy that takes to increase it from here to 20 should be 3u. So you're all wrong. Even myself, yes. Including myself. Bro. You can't tell it like that. Huh? It should be 3u, yes. Correct. Can you make a may gap එක තමයි 50.
කියන්නේ
මෙතන ඉඳන් මෙතනටම තමයි අපි ගත්තේ දැන් I took it like from here to here it's 200. It's not. It's from 0 to 20 it's
0 to 10 එක හොයනවා.
ඔව්.
ඒකට 0 to 20 හොයලා
ඔව්.
එකෙන්
ඩිෆරන්ස් එක තමයි
0
ගන්න.
to 10 එක අඩුවද?
ඔව්. ඩිෆරන්ස් එක ගන්න ඕන. එනර්ජි ඩිෆරන්ස් එක අරගෙන තමයි බලන්න ඕන. So the complete energy here is 200. The complete energy is here is 50. Yeah, the energy difference එක ගන්න එපේ. Energy difference එක තමයි බලන්න ඕන. Yeah, Shiny, you're correct. Completely agree. So it should be 3U. 3U, 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 3U. The answer is 3, not 4. Good, da. And I'll put the Shiny's number to you people. She's 2026. Study online together. It's a good thing. And when you are going to Norelia, she's there. She's Norelia. Shiny Norelia, right? She's Norelia. That's what I mean. So when you go to Norelia, you happen there. When Shiny is coming, yeah, she's here. When Shiny is coming here, yeah. You also and Diana here. I'll get the number. I'll get the number. And then. Right? So shall we come to that essay part again? Back again. Where the essay is. This one. B part, right? Or is it the question A? No, so the question 4. Calculate the gravitation action for acting on an object. Ikaran, yeah, that's it. This is the part B, yes. Do it here. Yes.
answers අපි root value එකකින් කියන්නද නැත්නම් decimals වලින් කියන්න velocity එක?
Essays. Decimals. essay වල search වලින් උත්තර තියන්න එපා. decimals වලට convert කරන්න. If they ask in search, that's fine, but if not, may put it in decimals.
21.2. ආයෙ opposite කරා. describe the sentence value.
And the guys, not the guys, the girls. I've been needing a favor from you two. We're gonna do a simple video on why you selected technology and why English medium, and how do you feel the class. Yeah. Can do no? Thanks. That'll be really helpful because, yeah, shall we? Yeah, after the class. What's your place anyhow? We go just the same way, don't worry. Why do? You have to practice? No, you don't have to practice. Just be. Why do? You look okay.
අද එක්කෙනෙක් කරන්න ඕනේ මේ
Avishka, we'll do a video. 1, 2, 3. 3 other. Even you can do. If you can stay. Why not? Prove. Get me famous. Within the year.
කොහොමද කියන්නේ මම තාට දුන්නා
Tell your gut feeling, that's enough.
මම කලින් කියන්නේ
කලම්බ කැම්පස් යන්න ඕනේ ඉච්චරයි
Oh.
ඒ වෙලේ කියන්නේ
Ipa. Karambu campus.
අපිට ජබ් වෙන්න ඕනේ කියන්නේ කොළඹ යන්න
ඒක උරගත්තේ
Eh? Why though?
මම ඇයි උරගත්තේ
What's the issue?
easiest way to go to campus
The appearance. Appearance.
මන්නන් ටෙක් කරන්න ගත්තේ
Appearance.
මන්නන් සෙට් ටෙක් කරන්න ගත්තේ
Colombo University Siddhi.
easiest way to get to campus
Yeah.
සර් තමයි
Yes, yes. That's the truth. Don't say it because I said it. It's the truth. On the way.
නෑ මම සිනාවට ටෙක් කරන්නේ පොඩ්ඩක් හරි ඉතින් කමාසර් කියන්න හරි ඉතින් දවසක් කමාසර් සිවිල් ගත්තද සීතු නැත්තාගත්ත ටැට් පොඩක් කිව්වා මම කියලා
Dot together. Dembe. Isar puluwa. Dembe. Bro, you can get selected for a like somewhere here university if you worked enough. You have the brain, you don't have the gut.
මට ගට්ටි කියන්නේ
Where? I know where, but I mean, I don't see it. But you don't work, that's the issue.
ඔව් මම දැන් කරන්න පටන්
Then you prove it after like 1 year doing the exam.
මේකට හරි
Which one? Now make it. We'll discuss it.
එකයි දෙකයි ගන්න
Kai dekai. Eh?
මේ හරි උත්තරයක් ගන්න
Hey, velocity difference ne?
velocity ආර bounce back ඒතරේ energy
ඒ කියන්නේ එතකොට මෙතන 0 කියලා ගන්න potential energy. Previous kinetic energy minus the new kinetic energy. Now the new kinetic energy is half of the previous. Don't consider the potential energy because take that in like me. Take the
එකයි දෙකයි
400. I think.
නැත්නම් logic එක හරියට
First question is asking for the height. Ne 80 meters දාවේ. Okay. Second is asking for the ආපහු එයා ground එකට වැටෙනවානේ. එතකොට velocity ගහන්නේ. That is only how many meters? 10 meters minus 70, that is 70 meters. I can't tell exactly. Like, you tell me if I'm going wrong. Done? Yes. Why there? What happened? Yes.
Levitation acceleration and
MGH maybe? To calculate the maximum height it will travel because it's thrown in a how many of a velocity? How much of a velocity? 40. So now we did sort of a question. Now the kinetic energy converts into potential energy. So like put an equation for equaling the kinetic energy to the MGH. So you get the height. Yeah. What do you mean? Gravitational acceleration එක කොහොමද ගන්නේ? Gravitational acceleration එක decrease වෙවි යන විදියටද? Can take.
ඔව් ඒකට ඉක්වේෂන් එකක් නැහැ නේ උනා. එතකොට
නෑ,
මේ
that's-
ස්පේස් වල ලියද්දී ඒක පාවිච්චි කරන්න බැයිද?
You will end up having less marks because they give marks for the equations and all. Still correct. That's the issue.
MCQ වලට ඒක හොඳයි.
හැබැයි ඒනට ඒකටත් වඩා ඔක ලේසියි. You just put an equation and cancel out everything and get the answer. Okay, okay.
එනර්ජි ලොස් එක.
ඔව්.
ඒක කඩුවේ එනර්ජි කඩු කිරීමද දැන් තියෙන එනර්ජි ලොස් වෙන්නේ.
ඔව්. හැබැයි දැන් මෙතන ලෙවල් එක 0 කියලා නෙමෙයිද ගත්තේ?
අපි හදුවම් බලන්න.
November. Shiny, put the answer. Put the first, second and third questions. Correct? All the answers? Eh?
අන්තිමේදී ඉතිහාස තියෙන එක හරියද කියලා මේ කල්පනා කරනවා.
කමන්නේ කරන්න. ඒ කියන්නේ මොකක් හරි ලියන්න ඈ. ඔව්. සමහර අයකට ලියනකොට හිතෙනවා. That's the thing. idea එකක් තියෙනවනේ හැමතිස්සෙම ලියන්න. ඒ කියන්නේ එතකොට මොකක් හරි එනවා මැදදී හරි. ඔකේ වැරද්දක් තියෙනවනම් හිතෙනවා මේක මෙහෙම දාලා හරියන්නේ නැහැ නේ කියලා. Is it a good answer? Sure නේ. First, second questions අවුලන්නේ. 1.81. Bro, how many dots are there? 1.81.6 meters? 1.816 meters. Is the first answer 1.816 meters? No? Sorry. The first, the first question is 81.6 meters, is it? 81.6. 80 exactly? Okay. Second one is 37.4 meters per second. Huh? That is correct. Okay. Third one? Try doing something. Just have a what do you call that? Cannibalism?
It's not something else. Something else.
Something else. I have a word in mouth, I can't tell. Hmm? 7 point? How much? 7? 7.84. 7484. 7.84. Okay. It's okay.
ෆ්‍රැක්ෂන් එකක් තියෙද්දි ස්ක්වයර් එකක් තියෙනකොට ඩිනොමිනේටර් එකත් ස්ක්වයර් වෙනවා.
Oh, දෙකම ස්ක්වයර් වෙනවා.
v ස්ක්වයර් 16.
Yes. So is it fine if you have a paper on two of the lessons, force and work power energy? What do you say? That's why I'm telling you have to study. Huh? Yes. Huh? End of the month. End of the month is better. Now listen. Oh. Don't make exam. Oh. Is it possible if you come in a different day? Can you? For the exam. Yeah, for the exam. Only for the exam. Because otherwise you'll have to allocate this time for that paper. That's. Right. So that's the thing. Now listen to this. Right. This is important. Now when you are going through theories and when you are answering the questions, now this thing happens. First thing is sometimes you don't know the theory when it comes to the questions, and you don't know how and what the hell is this. You feel the first feeling will be what the hell is this? You don't know the theory, right? And the second thing, if you improved it, you know the theory, but you don't know how to apply it. That's the second thing that comes. That's how when you feel, how the hell I do this? No? You are still in the second stage. Okay, that's a good thing. Now you know somewhat the theory. It's a good thing. So that is something you have to overcome with the practice, that you have to apply it in different ways. You apply it in one way, won't work. You do the second way, won't work. You do the third way, won't work. Doesn't matter, you do it until you get a correct answer, right? And that takes time, and it doesn't matter. If it takes time, let it take time. The brain cells gets time to improve, right? So more the time taken, better you will be, right? So don't rush it out. Don't try to do it, the easy way. The better things take time. That's how it really happens. So you have to, understand all the faults, right? You have to understand all the mistakes. That has to happen. The understanding always happens through the mistakes and the faults that you are doing. You have to understand all of that, right? So go through that and you will understand how to apply it. And when you know the pattern will continue. But only a few things will change in the question. That's what happens. Now, if you do all the questions here in the TUT and the question banks I'll be giving and the past papers, there will be a pattern that you will find it, right? You will understand this is a pattern. So because that's in a frame of the the syllabus. Under that frame of syllabus, there's a limitation that the questions can come. You will understand it when you do the questions. So once you know that pattern, you will somehow manage to answer a question inside that frame of the things that you understood, right? That's easy. In that level it will be easy, but small mistakes can be there, or some like critical questions can come. Steps ගන්න වැඩි වෙන ඒවා තියෙනවනේ. ඒ වගේ වුණා පස්සේ පොඩ්ඩක් critical වෙනවා. හැබැයි when you practice it little by little, you will understand the pattern. Once you understand the patterns, that's when you can do the questions, the real case, right? So but it takes time. That's true. I know it. So I want you to study it, go through it, do it by yourself as much as possible, and when you can't do it, refer the theory. Like even after referring the theory, if you can't do it, go through the videos if you can, and still if you can't understand it, ask for a friend. If he or she helps and you find it out, then that's okay, or otherwise you again ask me, right? So until you solve it somehow, you have to go through, right? So that's the way. So nothing comes easy. Now if you are thinking like it will be the A-levels will be like easy, like me reciting a poem or remembering some part of a dialogue, it's not like that. It doesn't happen in technology. These are like the science based subjects, right? Technology based subjects. So you have to use your brain. Nothing comes like gedi pitting in. You have to use your brain. So you have to develop it. So how the development happens? by going through the faults, right? So you have to go through it. That's how the the people are improving. Ne? So whenever you need any support, now these people are there now. Hopefully, I think they are good at things. You all good at force, right? No, this guy is not. Force, no trouble. Yeah, shape. So even this guy was, I won't tell right around there. Bro, shall I tell? Even yourself, when we are doing it, I can remember what happened when you are doing force. Oh.
පෝස් කරන්නේ ඒ අර මේක විතරයි ඉන්ක්ලයින් සීන් එක විතරයි ඉක්නොට් එක පුළුවන් ඉන්ක්ලයින් සීන් එක විතරයි කියලා
Right. So yeah, people were same. Like when I go to the time back, people were same. Yeah. So people are saying now they are improving. Now that's how education is, right? So you have to be like that. You have to start from the scratch and you have to improve it. Ne? Right. So try it. The first thing is you try it by yourself. Try hard. Do it really well. That is the improvement and that is the experience I want you to have. Not the මට නිකන් මේකේ බෝඩ් එකේ ඔක්කොම හදලා simple කරලා ඔක්කොම කරලා මට එහෙම දෙන්න ආස නැහැ. Because that is not education, that is not improving. And you will never improve like that. Huh? I see. Fine. Oh, which tata? Not the daddy, no. Okay. Her daddy, no, her father is calling. Right. Now you answer it fine. Okay, so the question, guys. So a rubber ball is thrown upward with a velocity of 40 meters per second. Now calculate the height it will travel. So this was like one of the previous questions. The kinetic energy converts into potential energy. So the at the maximum potential energy, kinetic energy becomes 0. So at the maximum potential energy, the highest height is there. So half mv square is equal to mgh. So mass to mass cancels out. So half v square is 40 nh square equals g is 10. And find the h. Now 40 square is 1600, isn't it? Divide by 2, 800 equals 10h. So it's 80 meters. So the height is 80 meters, is it? I don't know what happened to Shiny. 81.6 meters. How was it different? How is it different? Yeah, right? This is correct. Thrown upward with the velocity of 10, calculate the maximum height. Yes, 80. Right? So if it falls again and hits a concrete slab 10 meters above the ground, calculate the velocity with which it falls. So they are asking for the velocity at the height of 10 meters, which is 70 meters back, isn't it? Which is 70 meters back. So you have to take the yeah. Oh. Oh. So the height it will be yeah. So the mgh height will be 70 and the mv half mv square you have to find, right? So again it's mgh equals half mv square, so I'm gonna put the values on the equation because no space here. So half I had to put it anyway, mv square equals mgh. So mtm cancels out. So half v square we have to find. G is 10, the height is 70. So it's 1400. Now v square equals the root of 1004. Is it 400? Okay, the 100 have a root, but the 14 doesn't. And 14 can't be divided into any square values. Right? Decimal. Yeah, take the 10 root. Okay, 37.41 meters per second, because these are the essay questions. Don't go into search. Don't go into search because the essay questions should be in decimals. right? Not the search.
මම ඕනේ මේ හැන්දේ උත්තරේ.
කොහොමද?
මම හැන්දේ එතනදී
Put a secret way of doing it, huh?
ඕම දැන්නද මට ඔක තේරුන්නේ නැසෙනවා.
Bro, that is the simplest way possible. What did you do?
මම හැන්දුවේ කට 100 සමානයි half mv square එකතු කිරීමේ energy.
Oh, 800 කොහෙන්ද ආවේ?
ඒසෝ මේ මුළු එනර්ජි කට 100 කියලා මම හොයාගන්න පුළුවන්.
කොහොමද?
ඇයි බෝලි විසි කරන යන උඩ දාන්න නැහැ. ඊළ නැවතෙන
ඔයාගේ නතර ඉනිෂියල් එක 800 එක අපි
Cool.
80
half mv square
So how did you find that 800?
ඇයි බෝලේ උඩ දැම්මම 80
That's-
යනවනම් අපි
How did you know that it goes?
එන්නේ කපන්න පුළුවන්.
Bro, he did the same.
සමාන කරේ.
Oh. God. Now who's doing what? I don't know.
දෙවෙනි වෙලදී දෙක
Bro, so it's the same. It's the same. Now you see, it's the same. Half mv square equals mgh. You have put the same equation.
ඒක මොකද half mv square mgh.
Now you have put the same equation.
මම දැක්කද දිනේ නෙමෙයි.
Nothing. Half mv square.
මොකද්ද?
M.
මම කියන්නේ දෙවෙනි ගාන.
Bro, this is the first question.
අපි පළවෙනි එක දෙන්න.
And make a දෙවෙනි ගාන.
ඔව්.
හරි ඒකේ 800 good. That's fine. Yeah, that's correct.
ඔය මොකද ඔතන කියන්නේ? සර් කරන්නේ.
ඒ කියන්නේ මේකේ මම ගත්තේ height එක ගෙලිම 70 කියලා. මෙතන ඉඳන් මෙතනට 10 meters නැහැනේ. ඒතකොට එයා 70 meters පල්ලෙහාට වැටෙනවා කියලා තමයි ගත්තේ. Now this one is somewhat better than taking 70. Because he have taken it like this. So from the height, 800 joules ne
70 ගාන කොහොමද?
70 එකයි මෙතන ඉඳන් මෙතනට මෙයාගේ height එක තියෙන්නේ 70 නේ. ඒ height එකේ potential energy එක convert වෙන්නේ kinetic energy වලට. So we took only that one. So මෙයාට තියෙන්නේ maximum energy එක 800 නේ. So that is equal to half mv square. What happens? Huh? I don't know. What happens? Okay. So half mv square at the the පොතටත් වෙනවනේ. Half mv square 10 meters plus the mgh height of 10 meters. හරිනේ දැන් මේකෙන් අඩු වෙනවනේ. So it's good. That is the thinking. You don't have to do it all the way that I do it. You have to think and use the theories and do it your way. That's good. That's real learning. Nice. Thumbs up. High five. Okay. Right? So, yeah, the velocity is 37.4 and even Shiny is texting, oh sorry sir, the calculator had a value 1 before I did the calculation, I forgot the clear, that's fine. So he said wrong if we take 9 point, no you can't. So 9.8 you can take when you go to the universities, if you be a physicist. Now you have to take, no, they all taking 10. For now we just, for A-levels you just take only the 10. Now the meeting is going to end up in 3 minutes, is it? Huh? Is it 5:30 now? So we started late, we can run for a bit more, right? Would this one cancel out? I think, I think, huh? Okay then, okay, we'll finish it. So the ball bounces back with half of its velocity after hitting the concrete floor. Calculate the energy loss during the bounce. Now we found the energy here, right?
දෙකටම මේ mv square දාලා දෙක equal කරලා මේ නෑ මම half mv square දෙකටම දාලා half velocity නේ.
Hmm.
එතන මේක 37 divided by 2 square කරලා ඒකෙන් kinetic energy දෝරලා I4 මේ 37.41 ඒක දාලා වෙනම කරේ දෙක අඩු කරනවා.
ඒ කියන්නේ මේකේ kinetic energy එකයි මේකේ half එකේ kinetic energy එකයි difference එකයි. ඔව් ඒකේ difference එක ගත්තා නම් හරි. 1cc/. We'll calculate it in the next week because we are finishing in 2 minutes. හරිද? velocity දෙක අරගෙන kinetic energy දෙක අරගෙන difference එක ගන්න තියෙනවා. Do it by yourself. Think. Right. Okay. So yeah. So then see you guys on next week, and we are starting a new lesson. I heard it. Right. So we are starting a new lesson by next week. The what? Rotational motion, the circular motion. Huh? We are starting soon. Next month. So, huh?
ෆෝන් එකේ ඉතින් දැන් ජූන් එකේ.
So the week after next, we'll be starting the week after, not the week after next. Most probably the next week we are starting a new lesson. This circular motion, right? So get ready for that. Oh yes. Completely by yourself. Do it, huh? Right. Next month, starting for sure.
You're going to give a paper, so next week is the last week, right?
Is it? No. We have another week to go. It's till 15. Hey then, adios, people. Yeah. I think. Is it finished? I don't know if you have texted. You're leaving. Come. You gonna leave or stay for the video?
Like, I have to stay. Oh,
Can you?
I'm
1 minute second, huh? Shall I keep her for the video? Is it fine?
going to next week.
Yeah. Even like if she was there, you had to do it alone by yourself.
සර් ප්‍රශ්න අහන්න අපිට දෙන්න තියෙන්නේ.
Nah.
ඔව් සර් ප්‍රශ්න දෙන්න අපිට දෙන්න. ඒක රීස්. එහෙම.
Okay, even fine.
සර් ප්‍රශ්න අහන්න. හා කරු.
So, I don't know.
මට දෙක පාන්න ඕනේ.
Ah, fine. I'll take the boys for today. I'll take the boys for today. Okay. अभी पेनी जोगी नहीं तैयार करना वॉइस कट गया हैं why no it's nothing like that so we finish it shall we
ටෙක් දෙක කියන